All right, part 3, equivalence. So in equivalence here, we have the exact same amount of base as we do acid. So 40 milliliters of base, 40 milliliters of acid. So 40 milliliters of acetic acid, right, gives us 0.004 moles or 4 millimoles. It also gives us 4 millimoles or 4.004 moles of base hydroxide. All right, our reaction here. Same reaction, acetic acid plus your strong base, hydroxide, going to acetate and water. In our ice table, we have 0.004 moles of both acetic acid and hydroxide, or 4 millimoles if you're using the millimoles, if you want to do that. Well, they're both present in the right stoichiometric amount. This is wonderful. Minus 0.004, minus 0.004, however, plus 0.004. So I have no acetic acid, no hydroxide at equilibrium. However, I have 0.004 moles of my conjugate base. And this happens to be 80 milliliters, or 0.00080 liters. So it gives me 0.05 molar acetate. Now, if we go back up to this equilibrium constant expression here, can these be zero? So if I'm pointing at these, can that number be zero? No, because we have Ka, right? It can't be zero, right? And unfortunately, we have to do another calculation. And why do we have to do another calculation? Because this thing undergoes hydrolysis. Hydrolysis is simply just your reaction with water, right? So we have acetate plus water. What are our products going to be? Well, acetate is not going to be a proton donor. It's going to be a proton acceptor. So we're going to make CH3COOH. We'll make acetic acid again, and we're going to make OH minus. All right, so this is why your equivalence point in your titration, your pH, is slightly higher than 7. All right, ice table. Yet another one. So we have 0.05, 0 and 0, minus x plus x plus x, 0.05 minus x, x, and x. Now, this is no longer Ka, this is Kb. And Kb is equal to Kw over Ka, right? So Kb is equal to 1.0 times 10 to the negative 14th divided by 1.8 times 10 to the negative 5. That happens to be 5.6 times 10 to the minus 10. All right, so Kb expression is equal to acetic acid, hydroxide, all over acetate. So 5.6 times 10 to the negative 10 is equal to x squared all over 0.05 minus x. Can you approximate here? Yes, you can. It's way more 10 to the third, right? That's 10 to the 8th difference. Big difference. So I get 5.6 times 10 to the minus 10, right? Multiplied by 0.05, right? Do that. Square root both sides, you get the square root of x squared, which is x. So x happens to be 5.3 times 10 to the minus 6 molar, which is our hydroxide concentration. Because X, if you look, X here represents hydroxide. So, pH is equal to 14 minus the pOH. So pH is equal to 14 minus the negative log of the hydroxide concentration, which is 5.3 times 10 to the minus 6. And so the pH happens to be 8.7. So there's the equivalence point, which is the longest calculation of the titration.